Hello, pre-algebra students. Mr. Lawrence here with your next flipped lesson. And today we are adding and subtracting in scientific notation. And you might wonder why we did multiplication and division first. We did it first because it's a little bit easier. But the only reason this is tough is because sometimes kids don't understand what adding and subtracting is. Adding and subtracting, believe it or not, is just counting. That's all you're doing. That's all you're doing. You're just counting. For example, you just have to compare the things you're counting. If I have 3 stars and I have 2 more stars and I add them together, well, of course, that must mean that I have, where'd they go? 5 stars. Dun, 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 dun. There we go. 5 stars. 3 stars plus 2 stars equals 5 stars. I have to pay attention to the things I'm adding. Now, if I had 2 stars and 3 flowers, would I all of a sudden have 5 starlers or 5 flowers? No, of course not. 2 stars and 3 flowers is 2 stars and 3 flowers. You can't put them together because they're not like terms. Now, in scientific notation, we're going to run into situations where they're not like terms, and we're not going to be able to put things together. But we will be able to, sorry for repeating myself, something happened at home, I had to check out, to change some of the numbers and then make them like terms and then be able to add or subtract. So, let's see here. I've got 2 examples in green. And here's how I need you to think about this. Pay very close attention to this. We are going to be counting how many 10 to the 5ths we have. Why? Because both problems have a 10 to the 5th in it. We're going to count how many 10 to the 5ths we have. What's a 10 to the 5th? Well, it's a 1 followed by 1, 2, 3, 4, 5 zeros. So in other words, we're counting how many 100,000s we have. Well, if you look, we have 3 10 to the 5ths here. And here we have 2 10 to the 5ths. Now if I put them together, I'm going to have 5 10 to the 5ths. If you think about it, 3 times 10 to the 5th is like having 3 of these guys. Let me see if I can get 3. There's 2, 3. Then in the second quantity, I have 2 more of them. 1, 2. What do I have altogether? I have 5 100,000s. 5 times 100,000 is 500,000. If I go ahead and convert this number to from scientific notation to standard, remember the decimal point is sitting right after the 5, and I move 5 places, right? 1, 2, 3, 4, 5, and I fill in those little scoopies with zeros. Remember, I'm just like multiplying the number 5 by 100,000. Oh, I lost my 5. Let me put them back in there. And I'll put my commas in. 1, 2, 3, comma. Look, I get 500,000. Okay? So all I'm doing is counting how many 10 to the 5ths I have in the first group and how many 10 to the 5ths I have in the second group. Altogether, I have 5 10 to the 5ths. Or in standard form, 500,000. Take a look at number 2. What are we going to be counting on this one? We're going to be counting 10 to the 1sts. You know what 10 to the 1st power is, right? It's just plain old 10. Well, I have 7 here, and I have 12 more there. If I put them together, I must have 19 10 to the 1sts. Now, there's a problem with this answer. I haven't made any mistakes or done anything wrong. Hopefully, you can identify the problem. Think about it a second before I say it. The problem is right here. Remember, we always want the number to be like between 1.0 and 9.99. We never want to have a 2-digit number. So I'm going to locate my decimal point, and I'm going to divide the 19 by 10, which just moves the decimal point back 1 space. So my new number becomes 1 and 9/10. But if I multiply the 19 by 10, divide the 19 by 10, I have to multiply this guy by 10 because otherwise I change the value of the number. So the shortcut for that is that the 1, the exponent of 1, turns into a 2. I divide it by 10, I multiply by 10, it goes up by 1. And there is my answer in scientific notation. Now, if you wanted to check and see if you'd done it right, 7, 10 to the first would be 7 of these guys, right? Well, if you have 7 tens, don't you have 70? So I have, that's 7, one more. Okay, but that's really 70, right? So I'm just going to write a 70 right here. Okay, now here I have 12 10 to the firsts. Well, if I have 12 tens, don't I have 120? And if I have 120 plus 70, I must have 190. Well, let's convert this guy to standard notation. I know I want the decimal point to go 1, 2 places right. So I'll have a 1, a 9, and then a 0. And there we are. I get the same number in both cases, 190 and 190. Piece of cake stuff. All right, let's slide down to this one. This one looks a little bit stranger because I've got 10 to the 5ths here, but I only have 10 to the 4ths here. They're not like terms. This is the situation that I talked about earlier. I can't put them together right now because they're not like terms. But what I can do is I can decide to make this 10 to the 4th a 10 to the 5th. How would I do that? I'm going to multiply by 10, so it's going to turn into a 10 to the 5th. All right. But then I've got to divide the 12 by 10. I've got to do the opposite. So the 12 is going to become a 1.2. So my new problem becomes 8 times 10 to the 5th plus 1.2 times 10 to the 5th. And there you go. Now I've got 10 to the 5ths and 10 to the 5th, and I can add them up. And if I have 8 wholes and 1.2, I must have 9.2. Smart thing to do might be to line them up according to the decimal point. Add vertically, just like that. What am I counting? I'm counting 10 to the 5th, so my answer must be 9.2 times 10 to the 5th. All right, let's try one more addition one, and then we'll do one subtraction one. Okay, now this one looks a little strange, but remember, our 10 to the powers have to match. This is 10 to the 9th. This is 10 to the 7th. By the way, this is only true for addition and subtraction. For multiplication and division, they don't have to match because we're, in effect, not counting them. All right, so in this case, I need this 7 to turn into a 9. Well, I'm going to multiply it by 100, or 10 squared, which will raise that 2 numbers. But then I have to divide this guy by 100, causing that decimal point to move 2 places back. So my new problem becomes 1 and 23/100 times 10 to the 9th plus 0.0111 times 10 to the 9th. And now my exponents match, my 10 to the 9ths match. So for this one, I'm not going to do it in my head. I'm going to take the 1.23, and I'm going to line this one up with it. I'm going to line up the decimal points, and then my first digit is a 0. My next digit is a 1. Then I have 2 more 1s. What am I going to put in this above these 1s here? Well, I can always add zeros after a decimal point without changing the number. Now I'm ready to add. I'm going to get 1, I'm going to get 1, I'm going to get 4, I'm going to get 2, and 0.1 like that. So my answer is going to be 1.2411 times 10 to the 9th power. See how simple that is? You have to make your exponents match. If your exponents match, you can't do this. All right, I'm going to put up a subtraction problem. It's done the same way. We're going to suggest we do 6.54 times 10 to the 8th. And we're going to subtract 2.1 times 10 to the 7th. Okay, why don't you pause the video and see if you can do it. Here comes my solution. I have 10 to the 8th and 10 to the 7th. They don't match. I want to turn the 7 into an 8. I multiply by 10, raising the exponent by 1. But here I divide by 10, moving the decimal point one place to the left. Now I rewrite my problem. 6 54/100ths minus, lining up my decimal points, 21.21 I'm going to go ahead and subtract. 4 minus 1 is 3. 5 minus 2 is 3. Decimal point stays the same. 6 comes down because there's nothing here. In effect, there's a 0. And then what am I counting? I'm counting 10 to the 8th. And there you go. All right, we're going to get a little bit of practice with this. The good news is if you type these problems in your calculator exactly as they're written, it'll be super easy to know if you're doing it right or not, especially on the TI-30X2Ss. All right, Mr. Lawrence signing off. Have a good night, everybody.